all of you. Thank you. This Saturday afternoon for our first session of exam prep. As you guys all know, we're going to do a 1.5 hour session today, and then we're going to do another 1.5 hour session next Saturday. So today's session focuses mainly on paper 1 and on the topics that we've covered in Watobe. So I've included some grade 11 work, solving with X, because that's always part of our grade 12 exam, and then a sort of more difficult question on surds. And then we're going to go off and have a look at sequences and series for the remainder of the time. And then next week, I'm going to focus on trig and Euclidean geometry. I don't know how much we'll be able to get through under both topics in an hour and a half, but anyway, we'll do our very best. So as I say, it's really nice to have you all with us. I've got Kat here as our TA today, so a wonderful warm welcome to Kat. Thank you for being here and for helping us, and she'll keep an eye on the chat and just sort of help me monitor things. So yeah, if you guys got any questions, please don't be shy, don't be afraid to stop me and ask questions or to put something in the chat. And both Kat and I will endeavour to do our best to be able to help you prepare for the upcoming exams. Okay, so you were supposed to have been sent a copy of this exam prep document before the time. Is that correct? Did everybody receive this? So you know the questions beforehand. Is that correct? Yes, no? Yes? Okay, cool. Kanyisile. So yes, Mark says yes as well. All right, cool. I just as far as pronunciations are concerned, sorry, is it Diao? Leroy, did I pronounce that correctly? What do you like to be called? Okay, so Tabile is saying yes, and Tabaleng, Leroy is better. Okay, all right, that's fine. I'm sorry, I didn't know how to pronounce your first name, so Leroy is fine. Cool. So have you guys had a chance to work through any of, cool, Michelle, have you had a chance to work through any of these questions yet? Or is there anything that you've sort of looked at and you said, that's interesting. How would I do that particular question? Is there anybody who'd like to kick us off and tell us where to start? Or what I can do is I can give you the answers for like the first 3 questions, and then we can talk about the 4th one. Okay, so question 3. Okay, so Samkelo says 1.1.4. Sure, question 3, perfect. All right, so I'll take your suggestion. So let's start with 1.1.4 because that is something that's a little bit unusual, which is one of the reasons why I had included it here. And then we'll go, down to question 3. Hey, that's a nice inequalities, please. Sure, in Tabaleng, not a problem. All right, so we've got a couple of inequalities today. There's one here, 113, and then there's going to be an inequality question later on in sequences and series as well. All right, so let me just kick it off with question 113. Let's do it here on the side. So question 1.1.3. So we're solving for those values of x where 4x minus x squared is greater than or equal to 0. So there are a couple of approaches here. What you could do if you wanted to before you factorize is you could multiply through by -1. That just makes it a little bit easier to factorize to find your CVs. But if you don't want to do that, you can go ahead and work with it in this way as well. But I think it's a little bit easier if you do multiply through by -1. So that would give us positive x squared minus 4x. And then remember, when we multiply or divide by negatives, we have to change our inequality sign around. So that would end up being smaller than or equal to 0. Taking out our x, that gives us x minus 4 in brackets. And now we have 2 CVs, okay, 2 critical values where x is equal to 0 or where x is equal to 4. So these are the points at which the function changes sign from being positive to being negative. So if I sketch my function now and I draw my x-axis, there's my x-axis. 0 would have to be this one on the left. 4 would have to be that one on the right. And those values of x for which y is going to be negative or equal to 0 will be between 0 and 4. Okay, so between when x is between 0 and 4, the corresponding y's outputs are negative. All right, that's what the question is asking us. So here we would say when x is a number that is greater than or equal to 0, but smaller than or equal to 4. Okay, so 3 marks here. Normally what would happen, well, there would obviously have to be a mark for your answer. There would be a mark for factorizing, and then there's usually a mark for the diagram as well. Okay, everybody happy with that? Let's barrel on into question 114, and I'll squeeze that in over here. Yeah, absolutely, cats. Okay, so yeah, it would be sad-faced and then it would be the other way around. Okay, so in question 114, the first thing that we would need to do is get that 5 to the x plus 1 out of the denominator. So we could do that by cross multiplying. So this leaves us with 5 to the 2x minus 1 equals 4 times 5 to the x plus 1. Removing our brackets, that gives us 5 to the 2x minus 1 equals 4 times 5 to the x plus 4. Now, at this point, we need to recognize what it is that we are looking at. And the 5 to the 2x is the giveaway, right? So if we've got a base and it's to the power of 2x, then what they are trying to imply here is that we are working with a trinomial. Okay, so what we want to do is we want to get it into standard form, and then I'm going to show you what it looks like algebraically. All right, so I'm going to pull my terms all onto one side, so that's 5 to the 2x minus 4 times 5 to the x. And when 4 goes over to the other side, it would be minus 5 equals 0. So now, algebraically, that is identical to x squared, maybe x was a bad example, minus 4x minus 5 equals 0. So in other words, we are saying let 5 to the x, so we shouldn't say let it be x, we should say let it be y or some other value. But this is essentially how we're going to solve this problem. And just like we would factorize the green trinomial, and we'd have 2 brackets, and in the one bracket of 5 and in the other bracket of 1, because the middle term is negative, that's got to be minus and that's got to be 1, it would be exactly the same thing for the purple, in which case x would be equal to 5 or x would be equal to negative 1, except that we're not solving for x, we're solving for 5 to the 2x. So in essence, what we really do have here, and I'm going to rub this line out, what we've got here, and just rewrite it again, is we've got 5 to the x in one bracket and 5 to the x in the other bracket. Remember, when we multiply like bases, we add our exponents. So if I put the 5 here and the 1 over there, then it's the 5 that had to be the negative and that 1 that had to be the positive. Okay, so either 5 to the x is equal to 5 to the 1, in which case x is equal to 1, or 5 to the x is equal to negative 1. So now the question becomes, is it possible for me to take a base and raise it to an exponent and get a negative answer? That can't happen. Okay, so no matter the value of x, I cannot get a negative answer. So for this one, we would say that there is no solution. Or if you said that 5 to the x may not equal negative 1, that would be the same thing. All right. Yeah, you could use the K method too. Absolutely, Leroy. Absolutely. 100%. That would work too in this case. All right. So here I would say there would have to be a mark for multiplying. There's always an accuracy mark on this line for your factors. There'd have to be a mark for saying no solution. There'd have to be a mark for that. So what does that sort of leave us? It leaves us with standard form. Is that 5, 1, 2, 3, 4, 5? Yeah, I would say those would be where the marks would be allocated in this case. Very, very important, matrix. When you are working and solving for x and you've factorized or you've used the quadratic formula, don't forget the equal 0. Okay, it's a mistake that a lot of matrics make. And in matric level, they give you an accuracy. So like this line here that I'm highlighting in yellow with your factors in it, they give you an accuracy on that line. So if you leave off the equal 0, boom, that's a mark gone. Okay, and as we all know, those marks sort of tend to start adding up pretty quickly. So we don't want to start hemorrhaging marks right at the beginning of the paper. Okay, let's just have a see where everybody is. Oh, it's out of 3. Sorry, I'm looking at the simultaneous. Okay, so in that case, I would say probably for cross multiplying, for your factors, and then for both answers is probably where they would have allocated the marks then. Sorry guys, I was looking at this 5 over here and trying to make 5 marks out of it. Okay, all right, everybody good with that? All right, let's move on to the next question. Okay, this is a really cool question, I think, and something that's just a little bit different. Okay, so a rectangular box has dimensions A, B, and C. The area of the surfaces are 2 root 10, so that's the bit at the top, 3 root 2, those are the sides, and 6 root 5, so that's the one in front and the one behind. They're asking us to calculate, without using a calculator, the volume of the rectangular box. All right, so we've been given surface area and we want volume. Well, what do we know about volume of a rectangular prism? How would we calculate that? What formula would we use for volume? Can anyone tell me? There we go. Well done, Aisha. Perfect. Okay, so that's exactly it. Volume is length times breadth times height. That's what they want from us. And in the case of this, what they want is A times B times C. So that's what we want. We need to know the value of A, the value of B, and the value of C. All right, but the answers that they've given, or the information that they've given us area. All right, so 6 root 5 represents the product of which two things? Remember, area is used. Area, well, when we work with area, how do we calculate area? Area is of a rectangle, it's length times breadth, isn't it? So if we take the area of the face that we're looking at, which is 6 root 5, which two sides did we need to multiply together to get 6 root 5? Anyone know? Exactly, Tamika. Okay, so I don't know if the rest of you seen Tamika put her answer in the chat. A and C, quite right. So when we multiply side A with side C, we get 6 root 5. Cool, Tamika, good starting point. All right. So now we can do the same for all these sides. So 3 root 2 is the product of which two sides now? BC. BC. And the one at the top, 2 root 10, is the product of, yeah, C and B, Michelle, that's quite right. The one at the top is the product of which two sides, matrix? Absolutely, can you see it? Quite right, Aisha, A and B. So now we look at this information and we say, okay, well, we've got AC is 6 root 5, BC is 3 root 2, and AB is 2 root 10. But we want ABC. We don't want AC, BC, AB. We want ABC. So either we need to rearrange and work in terms of one letter, or there's another way that we could look at this as well. What do you guys want to do from here? Do you want to rearrange and sub in? Or how else do you think we're going to get our A times B times C on its own? Any ideas? So if I want the product of A, B, and C, then I need to times things together, don't I? Right? So I've got to multiply together AC with BC with AB. And if I do that, I get 6 root 5 times 3 root 2 times 2 root 10. So A times A is A squared, and B times B is B squared, and C times C is C squared. And when I times all these surds together, I'm going to say 6 times 3 times 2 is going to leave me with 36. And then with my roots, root 5 times root 2 times root 10 is going to give me root 100. Does that make sense to everybody? Now that I've got A, B, and C all next to one another, what I could do is this. I could say this is actually ABC squared. And the square root of 100 is 10, so this is going to be 360. Remember, I want ABC. Okay, that's what volume represents in this case. So I'm solving for ABC. So in order to solve for ABC now, I need to take the square root on the left and the square root on the right. So now I'm going to end up with ABC, which represents volume. And the square root of 360 is going to end up being 6 root 10, like so. Exactly 360. Does that make sense to everybody? Yes, okay. Cool. So yeah, so that's how we would do question 1.3. Any questions you want to ask me about how we've done that? We're ready to move on. Now, in the chat earlier, someone said, I just want to go back and have a look. Inequalities 1.3, so that was Leroy. Okay, all right, that's fine. So we've done 113, 114, 1.3. Okay, so we've done sort of the more difficult questions here, right? Do you want me to revise? What's the answer for 1.2? Can you see the answer is, give me 1 second. Either x was equal to 5,12 or x was equal to negative 0,78. Oh, do you want me to do that one? All right, that's fine, not a problem. Let's go back and have a look at it. So here, can you see the hint in this question? The big hint in this question is that they have asked you to do it correct to 2 decimal places. So the moment you see that, it means that they want you to use the quadratic formula. It's the only way. So if a question in question number 1 has corrected 2 decimal places next to it, they want you to use the quadratic formula. It doesn't factorize. Okay, so what I'm going to do is I'm going to rub this out because I know you guys have got that already. And let's just quickly go through how we would answer this particular question. Okay, so we can't sub into the quadratic formula until it's in standard form. So we'd first have to multiply everything out. So multiplying out the brackets on the left-hand side would give us 3x squared minus 12x minus 1, so that would be minus 13x in the middle. Then plus 4. And then we're going to bring that 16 over from the other side and make it equal to 0. So this leaves us with 3x squared minus 13x minus 12 equals 0. All right. And, oh, yeah.
I think they wanted 1.2.
Oh, 1.2. Oh,
yes.
sorry. Oh, sorry. Thank you for interrupting me. I haven't got my glasses on. I should have them on, shouldn't I? Sorry, can you see there? Okay, 1.2. Okay, so as follows. You should have had y equals minus 1 over 3, or y is equal to negative 1. And then x is equal to 3, or x is equal to 5. Do you want me to say that again? Okay, so either y was equal to minus 1 over 3 or negative 1, and x was 3 or 5. Yes.
Ma'am, can we work through it?
Yeah, sure.
Yeah.
Sure. No problem. Okay, let me just... Okay, so with questions like this, the only way that you can solve them is by substitution, okay, because you've got one linear equation and one quadratic equation. So you can't solve them by elimination. So what we would want to do is make this x the subject of the formula, and we'd get a mark for that, for saying x is equal to 2 minus 3y. And then we're going to go and sub it in. So x squared gives us 2 minus 3y squared plus 4, and then what I would do here is I would pull that y to the front and then put the bracket at the back, okay? So x is 2 minus 3y minus 5 equals 0. So a mark for that, a mark for subbing in. So now squaring our binomial, if you remember, it's square, double square. So square the first term, multiply them together and double it, so that'll be minus 12y plus 9y squared plus 4y times 2 is 8y, and then 4y minus 3 times negative 3y will be minus 12y squared, and then we've got our minus 5 on the end like so. Okay, so that means 12 plus 9, that's going to put us at 21y squared.
They're different signs.
Pardon?
It's a positive and a negative.
Sorry, I should really put my glasses on, shouldn't I? It's negative, so it's positive 9, negative 12. Sorry, so it's minus 3y squared. Minus 3y squared. Thank you. And then we've got minus 12y plus 8y. So that gives us negative 4y. And then as far as our constant is concerned, we've got 4 take away 5, which would leave us with negative 1. I think it's easier to factorize when we do not have a negative number in front of the square term. So I would divide through by negative 1. This would leave us with 3y squared plus 4y plus 1 equals 0. And now we need to go and factorize. So up here we would have 3y in one bracket and y in the other. And to get 1, it can only be 1 and 1. And since it's plus, it has to be plus here and plus there. Okay, so 3y squared plus 3y plus 1y would give us the 4y. And positive 1 times positive 1 is positive 1. So that's why y would be equal to negative 1 over 3. Can you see there? Or negative 1. And then you would need to go back and go and sub in here, that I'm just highlighting in pink, for your corresponding x's. Okay, so x would be equal to 2 minus 3 times minus 1 over 3. Okay, so that would leave us with 2 plus 1, which is why we had 3 as an answer. Or over here, x would be equal to 2 minus 3 times negative 1. So that gives us 2 plus 3, which is 5. Okay, does that make sense? Cool, no problem. All right, so yeah, very important that we get those sorts of questions right. Okay, so yeah, you can see out of the first bit here, that's 22 marks. So if you take away that 5 for that difficult question on the rectangular prism, we really do want to have all the rest of these marks if possible. Okay, let's get on with it. Would you like me to do the quadratic number pattern? It's not a particularly difficult question. Or would you like to go ahead to the... Yes, please. Okay, all right, not a problem. So again, this is the sort of thing that 3.2, okay. 3.2. Yes, definitely we want to do that question. Cool. All right, let's just do this one first, and then we can double check that we are correct and fine. And 2-1, sorry, Michelle, you saying 2-1-2. Yes, I'm going to go through that now. Okay, so when they ask us to work out the fifth term in the pattern, they're basically wanting us to look at what's going on and what are we adding each time. So in this case here, we would have said term 2 minus term 1. So 29 minus 15 means that we added 14. And then if we say 41 minus 29, we added 12. So in other words, what we're adding here each time seems to be getting smaller. All right, we added 14, we added 12, we added 10. So in order to get to the next number here, we need to add, sorry, yes, we need to add 8. So this would have put us at 59. Like so. So the value of the fifth term, term 5, in this case would be 59. Then in question 212, it asks us to determine an expression for the nth term of the pattern in the form Tn equals an squared plus bn plus c. So we need the pattern that we've started developing up here. We've got 15, 29, 41, 51. Term 2 minus term 1 is 14. Term 3 minus term 2 is 12. And term 4 minus term 3 is 10. So here, 12 minus 14 is negative 2. And here, 10 minus 12 is also negative 2. So we would use our rules. So we would take 2a and we would make that equal to our second difference, in this case, negative 2. And that means that a would be equal to negative 1. So we always make 2a equal to our second difference. Then our next rule is 3a plus b. And we always make that equal to the first term of our first difference. So in other words, in this case, I need to make it equal to 14. Okay, so let's just do that and then we'll color it in. So our 14's got to go in there. I'm going to sub in our a. So 3 times negative 1 plus b is equal to 14. So if minus 3 plus b is 14, it means that b has got to be equal to 14 plus 3, which is 17. And our last rule here is make that purple. A plus B plus C. A plus B plus, sorry. A plus B plus C has to be equal to 15. And then again, we've got to go and sub in. So -1 plus 17 plus C is equal to 15. So that means that 16 plus C is equal to 15. So in this case, C would be equal to -1. So the nth term of the pattern in the form Tn equals an squared plus bn plus c, this would be the pattern. Tn equals -n squared plus 17n minus 1. Okay. And then here you would end up with, I'm sure they would give you an accuracy mark on that. And then I'm sure it would be CA marks on the rest of these. CA on that, it's out of 4, and then CA on that as well. Okay, so provided you didn't make any more mistakes, if you made one mistake and you carried it through correctly, you would still end up with all the marks. Okay, or 3 out of 4. Do you want me to do 2, 1, 3? It's really simple. You just got to sub in 27. Should I do that, or do you want me to move on? We can move on. Okay, cool. So I'm just having a look here. Okay, so Ayavuya, you've said 3, 1, 2. Absolutely. Okay, so this is a good question for us to do. Right, this sort of thing comes up every now and again. Okay, so 222 Chiamo. Okay. Let's just go back and get this one done. Is everybody okay with 224? Because I sort of thought I would have to end up doing that one as well. Yeah, no, I didn't think so. So yeah, let's do this question. And I think the best thing for us to do is to do it from start to finish. Cool, all right. No, because this is also, I mean, it's not straightforward. So please, yeah, let's work through this whole question, because each one sort of depends on the next one. All right, so let me just move this out the way a little bit. Okay, in the first instance here, they have given us a geometric sequence, and the pattern goes 36, -18, 9, etc., etc. So when they want us to determine the value of R, the common ratio, remember matrix, so important, okay? R is always calculated by dividing term 2 with term 1. Or you can say it's term 3 divided by term 2. Or if you say term 4 divided by term 3, it really doesn't matter. But it's got to be the next term divided by the previous term, all right, in every single situation. All right, so in this case here, we would have said that R is equal to -18 over +36, or if we'd said 9 over -18, it's the same thing, and that gives us -1 over 2. We mustn't forget to simplify. All right, now they've said to us, calculate n if Tn is 9 over 4096. So what they have given us here, this Tn, it is a term in the pattern. All right, so what's happening is this, all right, so 1 is going into this pattern and 36 is coming out, and 2 is going in and -18 is coming out, and 3 is going in and 9 is coming out, and somewhere all the way down here, I don't know where it is, we've got 9 over 4096 is our Tn, these are our Tn's, and they want us to calculate the relevant input, okay, or term number. Term number what? gives us a term value of 9/4096. Because we are dealing with a geometric sequence, we are working with Tn in the form AR to the n minus 1. And they are asking us to solve for n. So they've given us Tn is 9/4096. Okay, so we've got Tn, we've subbed it in. When we look back at our pattern, we can see that A is equal to 36. We calculated R in 221, it's minus 1/2. And we are being asked to solve for n, so n minus 1. Okay. What we want to do is we want to isolate the base with the exponent. Whenever we are solving for an exponent, we want to equate the bases so we can equate the exponents. That's always the idea. Okay, so I'm going to write here, you want to equate the bases so you can equate the exponents. All right, so because our base is being multiplied by 36, the opposite operation would be to divide both sides by 36. So now we've got our 9/4096, and we're going to divide that by 36. And that leaves us with a very, very tiny number. Okay, 1/. You should be wearing my glasses. I see 16384.
Yeah.
If I got that right. Okay, thank you, Kat. Equals -½ to the n minus 1. And now this is the trick, matrix, all right? What you want to do is you want to write 1/16,384 as base minus 1/2. The bases have to be identical, so your base is going to have to be negative as well, which means that this is going to have an exponent that is even in sign, all right? So what we can do is take that number, 16,384, and pop it into your calculator and press equals. Then you're going to press the shift button and press fact. So the fact button is activated by pressing shift and then pressing the minutes, degrees, seconds button. Are you all seeing, oh, whoopsie daisy, are you all seeing when you do that you are getting 16384 equals 2 to the power of 14? Do you see that? Cool. Can you see Len? No. Okay, so cool, Leroy. Okay, so can you see Len? You're going to press 16384, press equals. Okay, and then shift and then fact. Okay, all right. So, but we're not working with 16,384. Yes.
I'm getting a math error.
Are you putting in 1/16,384?
Yes, ma'am.
Okay, you can't do that. Okay,
oh,
your calculator can't do that for you. So it must just be the denominator by itself.
Oh.
Okay, so just put in the 16384 on its own and press equals.
Oh.
Okay, now you're getting 2 to the power of 14.
Yes, ma'am.
Okay, now I'm going to show you how we're going to use that information. All right. Okay, so because we are not working with 16,384, we're working with 1 out of 16,384. So that means that we can write this base as -1/2 to the power of 14. And because our exponent is an even number, we will get a positive outcome, which is this 1/16,384. Okay, so that's how you're going to use the calculator to work out Yes, I suppose you could use the log function. We can go and have a look at that now as well. That's not a problem. Okay, so yeah, you can always use logs to be able to work out exponents too. All right, now is equal to minus 1 over 2 into the minus 1. And now that we have equated the bases, let me highlight them in pink for you. Okay, we've equated the bases. Now we can equate the exponents. So hence, n minus 1 equals 14. So n has to be equal to 15. All right, so the 15th term in the pattern is 9 over 4,096. Okay, everybody happy with that? Any questions? All right, now they're asking us in 223 to calculate sum to infinity. Yes, cool beans. Okay, so now they want us to calculate sum to infinity. So this is not a particularly difficult question because all we've got to do is sub into, okay, Ayavua, you saying no. Okay, what's wrong? Ayavua, how can I help? Yes, Buhle. So in other words, if you, because it's 1 over, you have to write it as, because the number isn't 16,384, it's 1 over 16384. So that's why we would write it as 1 over 2. So that's to the power of 14, that's to the power of 14. So we just simply write it as 1 over 2 to the power of 14. Okay, but we can make it negative. And we have to do that in this case, because when we've got an even number of negatives that are being multiplied together, our final answer is going to be positive. Okay, so that's the idea there. Vua, where did I lose you? What's wrong? What are you not understanding? Equating our exponents. Okay, so what we're doing, Ayavua, is this. Okay, so essentially if they say to you, all right, solve this equation, all right, and they give you 3 to the x equals 9. You use the base as a guide to how to write the 9. So you know that 9 is 3 to the power of 2. So if 3 to the power of x is 3 to the power of 2, we have equated the bases, we've made the bases the same, and now we can equate the exponents. So now I'm allowed to deduce that x must be equal to 2. That's essentially what we're doing here. What else would you like me to show you, Ayavua? Where else? Or does that kind of, you sure you understand? Okay, all right. So that's essentially what we're doing. Because they've asked us to solve for n, the exponent, we want to equate the basis so we can equate the exponents. All right. Okay, you sure you're happy? Please do ask if there's anything that you do want to know. I do not mind going back and explaining it again. Okay, so question 223 is really a nice question because they want us to calculate the sum. Cool, I'm glad. They want us to calculate the sum to infinity. Okay, so question 2.2.3 now, sum to infinity. So we've got to sub into our formula for sum to infinity. And remember, we can only calculate a sum to infinity if r is a number that is greater than -1 or smaller than 1. Otherwise, it's not possible to calculate sum to infinity. So here, because r is equal to a -1/2, it is possible for us to calculate a sum to infinity. So the formula for sum to infinity is a over 1 minus r. So you would find that on your formula sheet. We know what a is. When we go back up here, we can see that a is equal to 36. 1 minus r, remember r is -1 over 2. And we pop that into our calculator and we end up with an answer of I get 24. No problem, Kayla. All right, so what I'm going to do, Kayla, I'll just scooch up for you quickly. We've done, sorry. So we started with, oh gosh, I've already rubbed it out. We started with question 113. Then here in pink, this is question 1.2. You can screenshot that. Then there's question 1.3, screenshot that. And now we've done question 2, so you can screenshot that. There's the rest of it. You want to screenshot that as well. And now we've just done this question 221, so you can screenshot that as well. Okay, you guys are also getting 24, that's cool. And then you can screenshot that too, Kayla. Okay. So you've arrived just in time for the nasty question 2.2.4. In Tabeling, it is A over 1 minus R. Don't get confused with the formula for sum for geometric series. So what I can do quickly, hang on a second. We did so much of this in the beginning. Let's just see if I've got a formula sheet here. There we go. Let's just grab that one. Control copy. And where do we want to go? Where were we there? All right. And let's pop this here for you. Okay, so these are the formulae that will be, well, actually, these are not all the formulae that will be on your sheet. In fact, when it comes to these formulae that I've just put on the screen now, this is not on your formula sheet. So working out the difference, that's not on, neither is that. But these ones are. So you will get TN for an arithmetic sequence. You will get that as well. I don't think that's on the formula sheet. This is TN for a geometric sequence, and here's SN. Okay, so I think this is what you're getting confused with, is this first one. But yeah, sum to infinity is 1 minus R. Okay, in Tabeling. So yeah, just be very careful about, no problem. I have a boy that I've taught this year, and when we were doing trig and we were doing compound angles, he copied one of the compound angle, I don't know if he copied it, but he wrote it down incorrectly. So yeah, you must just make sure that when you copy stuff off your formula sheet, just be really, really, really careful. Okay, because it is there for you to use. Okay. All right then. Well, in that case, I think we are ready to move on. Do you agree? We can have a look at this question over here. And I'd like to work through this question with you as well, from start to finish. And then we can go and have a look at whatever else we can do today. Question 3.1.1, where it says show that questions in maths are often a sticking point for students. And really, the way that you need to treat this question, Matrix, is you need to pretend like you don't know that P is 11. Okay, because if you use that 11 to work out anything in your answer, you're not actually proving, you're verifying. All right, so we don't, you know, are we still going to do 224? Hold on, what did I leave off? Oh, sorry, I'm busy jumping ahead here. Thank you. Sorry, guys. The most important question here, absolutely. Sorry. I got distracted when I went and looked at the formula sheet. Yes, absolutely. Let's do this before we move on. Okay, so question 224 is the last part of question 2.2. And let's just have a look carefully at what it is asking us to calculate, all right? So they want to know the value of term 1 plus term 3 plus term 5 plus term 7 all the way up to term 499 divided by term 2 plus term 4 plus term 6 plus term 8 all the way up to term 500. All right, so if we look at the yellow one on the top, all right, what is that the sum of? What sort of numbers are those? Odd numbers, exactly, absolutely. Okay, how many odd numbers would there be? How many odd numbers will there be if they're asking us to add term 1 to term 3 to term 5 to term 7? How many terms are there going to be? Aha, correct. Correct, Ryle. 250. Right, Tabile. Right, Makosandile. Perfect. Okay, so it's the sum of the odd numbers to 250. And similarly, down at the bottom, this would be the sum of even numbers or even terms to 250. Okay, so let's go and have a look at what we've got. Okay, just scooch over to the side here. Okay, so the first term is the number 36. The third term is the number 9. Okay, at the bottom, the first, so term number 2 is negative 18, and term number 4 would be what? Do you know how to extend this pattern a little bit further? Remember, our ratio is negative 1 over 2, all right? So the next term after 9, so let's just get rid of this over here. Okay, so term 1 is 36. Term 2 is negative 18. Term 3 is 9. So there's term 1, term 2, term 3. Okay, so that means that this is going to be negative, let's see if someone's put it in there, negative 4.5, absolutely, negative 9 over 2. All right, and then the next number is going to be positive 9 over 4. Does that make sense to everybody? Yes, okay, all right. So we are going to do the sum to 499 terms. So then here we've got negative 18, all right, plus negative 9 over 2, all right, plus whatever this is, and then here at the top, we've got 9 over 4, all right? So now we need to try and work out what kind of sum have we got at the top? Is it an arithmetic sum or is it a geometric sum? So in the numerator, what is that new pattern in the numerator? How could it be defined? Yes, it's going to be geometric, isn't it? Absolutely. All right. And remember, we want to do the sum to 250. Okay, so the sum to 250. So for any geometric pattern, sum, okay, is a over r to the n minus 1 over r minus 1. Again, I can also swap it around, but that's what we've got. Okay, so that means we need, at the top here, we need a, which is 36. All right, what's the value of r in this case? Maybe we should use a square bracket here. What's the value of r for this new pattern that we've made at the top? That's it, Tabile, 1 over 4. Okay, so now inside here we've got 1 over 4. And then remember, we already said that it was the sum to 250 terms, right? So this has got to be to the power of 250 minus 1. All over a quarter minus 1. Okay, so that is now our sum in the numerator. In the denominator, all right, let's have a look at what's going on here. Okay, a is our first term, so that's negative 18. What is our r value in this case? I'll also work it out. What are you guys getting? Cool, I'm also getting a quarter. I'm also getting a quarter. All right, so now at the bottom, we've got negative 18, open bracket, a quarter, also the sum to 250, right? So 250 minus 1 all over a quarter minus 1. Okay. Well, this is actually not nearly as scary as it looks. What can you see straight away that we could do here? Remember, this divide line in the middle here is this divide line over here. Okay. There's something that it's actually very easy here for us to do. Exactly, cancel brackets, right? And in fact, what we could do is we could cancel that and that. And we would be left with 36 over negative 18, which would give us an answer of negative 2. Exactly, can you see there? Okay. How does that sit with everybody? It's not the only way we could do this particular question. There's another way I think we could do it as well. If you'd like me to, how do we know that it adds up to 250? It's not that it adds up to 250, Michelle. It doesn't add up to 250. There are 250 terms. Okay, so go back and look at the yellow. All right, if we start counting at 1 and we're counting every odd number starting at 1, there are 250 numbers. Does that make sense? Okay, so there are 250 numbers being added together at the top, and there are 250 numbers being added together at the bottom. Okay, Michelle? Cool. Would you like me to show you another way that you could answer this question, or do you want me to move on? So I've just thought of something else we could do here as well. Choice is yours. Yeah, okay, cool. I think that's so important in maths, you know, is that when we can do it this way, well, how else could we do this particular question? All right, so what I'm going to do, is it okay if I rub 222 off and just write in this space here? I'm sort of presuming at this point, another way, please. Cool. All right, so Ayavua, there's a couple of people asking, that's fine, we'll move on soon. Okay, so I'm just going to get rid of all of this. Obviously, if you want to come back to this at any stage, you could watch the video again and then just stop it where you needed to. But I think it's cool to be able to look at another way that we can do this. What? There we go. Okay, so what we have is a plus ar squared plus ar to the power of 4. So that's what all of these are, isn't it? So term 1 is a, isn't it? Term 2 is ar. So here at the bottom, we've got ar. And then term 3 is ar squared. Term 4 is ar to the power of 4. So sorry, term 5 is ar to the power of 4. Term 4 is going to be ar to the power of 3. Term 6 is going to be ar to the power of 5. And so we would go on adding until we got to ar to the power of 500. And here at the bottom, it would be plus ar to the power of, it would be 499. Okay, so what we could do is we could take out a highest common factor. And at the bottom, did I make a mistake?
Yeah, there we go.
Yeah.
Isn't it usually n minus 1? So it would end at AR 498.
Sorry, 498.
At the top.
Yeah.
At the top, though.
At the, yeah,
And then at the bottom, it's 499.
Yes.
Yes.
Yeah, because it's n minus 1. Okay, so it's 499 minus 1 is 498, and 500 minus 1, absolutely. Okay, sorry, I'm being stupid. All right, so let's leave this as it is at the bottom. I mean, at the top. Sorry, it's been a long day. All right, plus AR to the 498. And then we can take out R at the bottom. And that will give us A plus, look here, AR squared plus AR to the power of 4 plus to AR to the power of 498 as well, isn't it? And then we could cancel the top bracket and the bottom bracket. And that would leave us with 1 over R. Okay, and remember R was negative 1 over 2, wasn't it? So that would be 1 over negative 1 over 2. And thus the final answer would also end up being negative 2. Okay, so that's another way that we could have done that question if you wanted to. All right. Don't know which one's a little bit easier. The first way is a bit more sort of cumbersome, but probably easier to understand. I don't know. But anyway, there we go. All right. How's everybody feeling? Are you happy? Is it making sense? Cool. Cool. It's a pleasure. It's a pleasure, Ryle. Nice. Thanks, guys. Okay, so let's march on then and go and have a look. Where did I put it now? There it is. Okay, let's go and have a look at this question over here. Cool. All right. Thanks for all the good thumbs ups and everything. All right. So question 3 now. The first 3 terms of an arithmetic sequence are 2p plus 3, p plus 6, and p minus 2. And as I was saying earlier, very important whenever a question tells you to show that in maths, and whether you are working in sequences and series, or you're working in trig, or anything, anywhere in maths, if the question says show that, it is asking you to prove. And when you prove, you are not allowed to use the information that they have given you. That is the conclusion they want you to arrive at. Okay, so you answer the question pretending like you don't know that P equals 11. Okay, that's what they're expecting you to do. So again, back to our basics. If they tell us that these are the first three terms of an arithmetic sequence, we know that in all arithmetic sequences, term 2 minus term 1 is term 3 minus term 2. Okay, so that's what we need to do here. So in 3.11, we are going to say, so this is term 1, this is term 2, this is term 3. So let's say we decide to say term 3 minus term 2 is term 2 minus term 1. And in my opinion, one of the biggest mistakes that students make in maths is that they do not use brackets when it's appropriate to do so. Okay, so remember, very, very important. Okay, if you are subtracting something and there's more than one term, you must use brackets. Okay, so that's one of the ways in which we get caught. So now removing our brackets, we've got P minus 2 minus P minus 6 is P plus 6 minus 2P minus 3. All right, so let's get the P's all onto one side and the numbers all onto the other side. So here we've got P minus P, which would obviously be 0, minus another P plus 2P. And this side here, we've got 6 minus 3, add 2, and then add 6. Okay, so this leaves us with a P on the left, doesn't it? Okay, no, a negative P on the left, no. A positive P on the left, yes. And then on the right-hand side, we've got 3 plus 2 is 5. That would be 11. Okay, so there we go. We're done. All right, so can you see how I did not use the 11 in any part in my solution? All right, I proved that it was true by other means, and that was by saying term 3 minus term 2 is term 2 minus term 1. Okay, so there would be no mark for that in this case. I'm assuming here the marks would have to be on this line over here, maybe on that line over there. I suppose either of these two would be sufficient. Okay, cool. Now for the inequality. So here it says to us, calculate the smallest value of n for which Tn is smaller than negative 55. Okay, so this is an inequality, and instead of them saying Tn equals negative 55, they're saying to us Tn needs to be smaller than negative 55. This is an arithmetic sequence, right? So as far as Tn is concerned, Tn equals, for an arithmetic sequence, let's just go and grab it up here.
A
plus n minus 1d. Okay, so we've got a plus n minus 1d, right? Here what we're doing is we're taking our a plus n minus 1d and we're solving for n when this is smaller than negative 55. So in order to be able to solve this for n, it means that we need to know what a and d are. And the only way that we can work out what a and d are is by taking the value of p and going and subbing it back in. Okay, so that means we have 2 times 11 plus 3 is term 1. So that gives us 25. And term 2 is going to be 11 plus 6, which is 17. And term 3 is going to be 11 minus 2, which is 9. So A is 25, isn't it? And D, our difference in this case is each time as we go from one term to the next, we are subtracting 8. Is that right, Kat?
Yes. Yes.
Cool. All right. So now, again, this is another place where we do not use brackets when it's appropriate for us to do so. Always put your D in brackets, guys. Okay, especially when it's negative. So we have 25 plus n minus 1 times -8. Now, if I didn't put these brackets here, I would end up taking 8 away instead of multiplying n minus 1 by -8. All right, so very, very different to subtract something than to multiply. So now that we start collecting, start removing brackets, we end up with 25, not plus, actually, 25 minus, rather, 8n plus 8 is smaller than -55. So that gives us -8n, and let's scooch those numbers over to the other side. So that means that we've got -55. I suppose I should write that down. -55 minus 25 minus 8. And that gives us -88. So we've got -8n is smaller than -88. And now, matrix, we need to solve for n by dividing by -8 on both sides. And remember, our inequality sign has to swing around. So n has to be greater than 11. Okay. So the smallest value of n, for which Tn is smaller than -55, n has to be greater than 11. Okay, does that make sense to everybody? All we need to do now is just sort of answer the question finally. All right, so we've just got, cool beans, we've just got one last thing to do here with question 312, because the question said to us that we need to work out the smallest value of n. So that means that the smallest value of n will be where n is equal to 12. Does that make sense to everyone? Okay, because it's got to be greater than 11, and remember, n always has to be a natural number. So n must be equal to 12 in this case. All good? Okay, all these thumbs ups. All right, lovely. Okay, guys, and now let's go and do that other monster of a question. Cool beans. All right. I hope these questions have challenged you a little bit. But not being so challenging that you feel like running away and crying. But yeah, this is the sort of level that you can expect in your June exams and in your trials, and certainly at the end of the year. Okay. Okay, so Aisha, they asked us for the smallest value of n. Okay, the smallest value of n. So remember, when we are calculating n has to be a natural number because it's term number 1, term number 2, term number 3, term number 4. So the next natural number that's greater than 11, the first natural number that's greater than 11 is 12. Okay, so term 12 will be the first term that is smaller than -55. Does that make sense? Okay. All right, so n has to be natural. So because it's greater than 11, it can't be 11. So the next biggest natural number is 12. Okay. All right, nice. So let's do this. Given that, so now we've got some sigma notation. Okay, so given that the sum 2 equals that, prove that equals 0. Okay. Nice question, isn't it? So they want us to prove that the sum to 15 terms of x minus 3k is equal to 0. Okay. So, is it all right if I clear a little bit of space here? The 311 and the orange writing. Just make some space here. There we go. Okay. So they want us to show that the sum to 15, starting off with k equals 1, is going to be equal to 0. So that would be the sum to 15 numbers if the sum to 6 equals the sum to 9. Okay. When it comes to sigma notation, the first thing that we normally want to do is we want to sub in, and we want to generate a pattern so that we can see exactly what the terms are that we're dealing with. All right. So the number at the top is the last number we sub in, and the number at the bottom is the first number that we sub in. So if we have a look at what we've got on the left-hand side, 1 would be the first thing we needed to sub in. So that would give us x minus 3 times 1 plus, next term, x minus 3 times 2 plus x minus 3 times 3 plus x minus 3 times 4 plus open, open, close, close, plus x minus 3 times 5. So sorry, I should have written here. So plus x minus 3 times the 6. So that's going to give us x plus 3 plus x minus 6.
It's minus 3, isn't it?
Of course. Sorry, Kat. There we go. X minus 9. X minus 12 plus x minus 15 plus x minus 18, okay, which gives us 1, 2, 3, 4, 5, 6x, and then let's just do this. So minus 3 minus 6 minus 9 minus 12 minus 15 minus 18 gives us negative 63. Okay, then when we do the sum to 9 terms, so starting off by subbing in 1, we are going to end up with all the same terms in the beginning, isn't it? So we're going to end up with the same terms for, Kat, just help me with this.
Yes,
Okay.
so you continue
So this is going to be the
7, 8,
same.
9. Yes.
So that'll be the same, that'll be the same. So it'll only be from where we're subbing in 7 where it's going to be different, isn't it?
Yes.
Okay, so that means we would end up with also x plus, oh, freak man, x minus 3 plus x minus 6. So hang on a second, no, wait. Well, if we've got that, then it means we're going to end up with the same sum here, which is 6x minus 63, isn't it?
Yes.
So this is, we can actually simplify this. So this is going to be 6x minus 63.
And then plus x minus, yeah.
So x minus 3 times 7.
7, yes.
Plus x times 3 minus 8 plus x, why am I writing 8? Plus x times 3 minus 9.
Yes.
Okay, so that means that we end up with 6x minus 63 plus 1, 2, so that's another 3 x's. And now we've got an additional negative 21 minus 24 minus 27 minus 72. Okay, so if these two are equal to one another, which they told us they are, then it means that 6x minus 63 is equal to 6x minus 63 plus 3x minus 72. So we have that. Thus, 3x minus 72 is equal to 0. Is everybody okay here? It's a bit of a monster, which means that 3x is equal to 72. So x would be equal to 24. Okay, so now let's go back, all right, and have a look at this sum to 15, okay? So we've got the sum to 15. And the pattern here is x minus 3k. And essentially, this is our left-hand side. And we want to prove that our left-hand side is equal to 0 so that it can be equal to the other left-hand side. All right. Now, the reason I say sum to 15 and I said sum to 6 and sum to 9 matrix is because remember with sigma notation, the number of terms in the pattern is the number at the top minus the number at the bottom plus 1. Okay, so it's not just the number at the top on its own. It depends on where you start subbing in. So that's why it's sum to 6, sum to 9, and sum to 15, because we started subbing in at 1. But if we'd started subbing in elsewhere, then it wouldn't be a sum to 6 or a sum to 9 or a sum to 15. Okay, so now they want us to calculate the sum to 15 of, all right, so this the first term is going to be 24 minus 3 times 1. And the second term is going to be 24 minus 3 times 2. And then the third term, blah, 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 blah. And then the very last term is going to be 24 minus 3. Okay, so that means that we've got 21 plus that would be 18, wouldn't it be? Plus 15, plus all these other terms in between. And then our last term would be negative 21. Did I work that out right? Yes, negative 21.
Yes.
Would be the last term in the pattern. There are 15 terms, okay? So when we look at this pattern, we can see that this is an arithmetic sum, okay, with a difference of negative 3 each time, all right? So what we want to do is we want to calculate the sum to 15. Okay, so that's going to be n over 2, whoopsie daisy, 15 rather. So that's going to be 15 over 2, open brackets, 2a plus n minus 1 d. And if this doesn't give us 0, I will cry. It should do. Okay, so let's just work that out. So 15 over 2.
Yep, it's 0.
It's 0. Fabulous. Equals the right-hand side. Okay, so we've managed to prove. Does that make sense? Do you want me to go back up? How are you guys feeling? Are there questions? Yes. Shall I go back up? Okay. All right. Okay, so that was sum to 6, and then sum to 9. Okay. Okay, good. You're feeling good. I'll do that. Oh, yes, this was, yes, can you see? Go for it.
Ma'am, I have a question.
Sure.
The fact that the sum of 6 and the sum of 9 is equal to 15, does it have any effect on this question in some way?
Oh, you mean because 6 plus 9 is 15?
Yes, ma'am. If we had to use those numbers, would we get any?
I see what you're doing. I'm just thinking this through. Can you see, Le? Yes, I think that has got something to do with it. I think that has got something to do with it, definitely. Because we've added everything together, haven't we? So yeah, 6 plus 9 would give us 15 in the same way that the sum to 6 plus the sum, but hang on, does that give us the sum to 15? Yeah, I suppose it does, doesn't it? Yes.
Ma'am, how would we go about it?
Well, I would do it just like we've done it over here. So I would go ahead by subbing in and working out, because you see what we did in the beginning, right? So this bit in the purple, right, that I've got written over here. So what I'm highlighting in blue, this over here is this. Okay, so in other words, what we've done is we have calculated that the sum to 6, where k equals 1 of x minus 3k, we have worked out that that is equal to 6x minus 63. All right, and as far as the next bit is concerned, okay, so this middle bit over here, which was sum to 9, that's what we've done over here. All right, so we've worked out that the sum to 9, subbing in from where k is equal to 1 of x minus 3k, we've worked out that that was 9x minus 135. And then they told us that those two are equal, right? So then we're going to make them equal to one another. So in other words, we're going to take 6x minus 63 and we're going to make it equal to 9x minus 135. And then we're going to solve for x. Okay, so it's exactly what we did. So on one side, we've got 9x minus 6x, and sorry, 9x minus 6x. And then on the other side, we've got minus 63 plus 135. And that's where we got the 3x was equal to 72. And then once we knew what x was, which was 24, we could then go back and go and sub that 24 in here. Okay, so we were doing the sum to 15, where x was equal to 24. All right, so remember we went and we subbed our 24 back in. All right, we worked out the first 3 terms in the pattern so we could see what A was, we could see what D was, and then we could go ahead and go and sub into sum to 15 and calculate the answer to be 0. Okay. And we finished just in time. Yeah, it's a pleasure, Kamisile, no problem. Are there any other questions that you guys would like to ask?